question number 236, lowest common ancestor of a binary tree. So given a binary tree, find the lowest common ancestor LCA of two given nodes in the tree. The definition of LCA is on Wikipedia, you can go and read it. The lowest common ancestor is defined between two nodes P and Q as the lowest node T that has both P and Q as descendants. So where we allow a node to be descendant of itself. In simple words, the 3 is there, na? So who are the descendants of 3? It means who are the child of the 3? 5 and 1. So who will be the ancestor of 5 and 1? 3. So lowest common ancestor is the ancestor which will come first. It will be the lowest common ancestor. Similarly, for 5 and 4, who will be the lowest common ancestor? For 4, it will be 5. But for 5, 5 can be ancestor of itself. Node to be descendant of itself, it means it can be descendant of itself, it can be ancestor of itself, vice versa. So 5 and 4, the answer will be 5 then. See, P is given 5, Q is given 1, then our answer will be 3. But if P is given 5 and Q is given 4, then our answer will be 5. Why the LCO of 5 and 4 is, since a node can be a descendant of itself, according to the definition, 5 can be itself, and fourth most common node between 4 and 5 will be the 5. Hence, our answer was 5 here. Okay, let's see how we can solve this. This question is kind of tricky because what you will think, first thing you will think, okay, I will traverse left side and right side and then I will find out the common node, the first common node between 5 and 1, correct? We will think like that. And you can see they already gave us where will be our two similar nodes, like P and Q are already given. So what we can do is, here itself in this function itself we can do recursive call. First thing which we need to do here is, we can say base conditions. What base condition will be? If suppose we have nothing in the root, there is no root itself, then we have to return null only. That will be the base condition, okay? Another thing is, suppose I am on 7, there is no left and there is no right, then what I will return? I will return 7 itself, na? So if, so another base condition will be, if there is no, so there will be no left or maybe no right, you can say, or maybe no right. Okay, this is the thing. Okay, sorry, I should have wrote this in this part. Yeah, like this. But before that, one thing which we need to handle is, suppose I got P and Q, suppose I got P as 3 and Q as 1, okay, in this place. So 3 will be my answer, but 3 is the root itself, so that will be also a base condition. If in case my root is equals to Q, which will be the P suppose, and root is, or maybe root is equals to Q, then we have to return root itself, that will be our answer, okay? What's the case is, if my root root itself is P, P or Q, okay? That's the one thing. Now we can do this part. For doing this part, first we need to traverse through the left and right part. So let's just write it like, we can create a tree node, left is equals to, and we can just do this same function, lowest common ancestor here. And what we will give it? We will give it node dot, sorry, root dot left comma P comma Q. Okay, let's just copy this part and paste it here also and make it right and right. So now we traversed through both the parts, okay, recursively traversing. left and right subtree. Okay, so what can be the possibility? First thing which we can see is if the value, if suppose I got a left node, suppose I have a left node. Okay, so if left, sorry, so if my left is not equals to null, or maybe my right is not equals to not equals to null, then I have to return what? Root, exactly. Okay, let's understand this condition first, because this is the main condition. So here we got output as 5, input as 5 and 1, and we need to find the lowest common ancestor. So what will happen, just you tell me, if I will be on the 3 and I did 3 dot left and 3 dot right, what this will return me? As we know, this 3 dot left will return me what? See, root, now root will become 5 and 5 is equals to p, so it will return me what? It will return me 5, the root. Here it will return me, similarly it will return me 1. And when my 3 dot left and right, I have values in them, and when I have values in them, they are not null. Hence, my root is the right answer, correct? So that's why I kept a root as the answer. Okay. Similarly, if we go here and check, in this case, what will happen? We are doing dry run now itself. What will happen in this case? Just tell me. 5 and 4. So first I will have 3. 3 will go here. 3 is left is this, and 3 is right is this one. Okay. So what will happen? In my left, if I go, I can get my root is equals to p, because root will become 5 now. So root is equals to p. So we got 5 again. And here what will happen? Here, if my root is equals to p, I got 5. And now my right part is also, I will get 4. Obviously, I will get 4. But does that matter? No, that doesn't matter. Why it doesn't matter is, suppose if my left itself is not null. So my right now also my left is not null and my right is also not null. So both are not null. It means I have a value in this part. And hence my root will be the answer. That's how it works. But let's just go even much more deeper in the right part, because I think so people may be getting confused how, Tushar, you are saying right is also present. So let's just see. When I came from 3 to 5th node, so third, 5th was my answer for one part. But this time, if I go for the left part, now you can see is, in left I got 1. For 1 I had 0 and 8 as the left and right part. No, nowhere, nowhere, sorry, here the Q was 4, correct? So nowhere in the question I got 4. Hence, my right part for the second dry run was failing. So this will be not the answer. But the point was, my left part was there. So my right part was returning what? My right part was returning null in this condition. So this condition will not work. But if we can write here, if my left is not equals to null, but my right is null, so we will just return left. Okay, and otherwise what we will return? We will return right. So this is how we will handle it. Okay, if for this question, now for this particular test case, we will do dry run much better. Okay, let's do dry run even better, because this question, this part is tricky. Dry run. Okay, how it will work? See, first we got h3 as our value, as our root. Okay, h3 will trigger what? H3 will trigger h5 as its left and h1 as its right. Okay, but the point is, left is the same as the p value, so we have 5 in the host option. But for the right part we have nothing, we have null, because in right part we don't have that value, so we will get null. But the point is, in h5 we know one more thing. So in h5 we can see that we have H6 and H2 also, H2 also, and then in my H2 I have H7 comma H4. So we can know that 5 is the only option which we have, which is having 4 and 5 both. So instead of verifying whether we have the second node or not, we can just rest assured that we got the first one, and in the right tree we have no value. That's why we got null. So obviously in the left tree we will have some value, and the 5 one is the nearest one, so we will have 5 as our answer. Hence, for this 3, we got our answer as 5. Okay. This is was the dry run for this question. For this one, it is pretty simple. 5 and 1 both are having root node having left and right both. Hence, root node is the answer. Okay, let me just write it here quickly. Root left plus right both having values. Hence, root is nearest ancestor. Only left node had value and right subtree did not had q p or q p or q. Hence left will be nearest ancestor. Okay, if not left, left then it will be the right. No other options are there. Options are left. Okay. So this was the, I think so this is pretty much, and I hope so it should run. Let's see. Submit. Not submit. First we will run. Any issues will be there. We will resolve it. Okay, our one test case failed. Let's decode it. So what happened was, okay. Mm, let's just go and see our code. So if my P or Q is similar, we are returning root. That was the right part. Otherwise, we are calling these functions on root.left and root.right. If my left is null and right is null, then my root will be the answer. If my left is not null, then my left will be the answer. Otherwise, my right will be the answer. Okay, and in what part we failed? In P and 4, our output should be 5, but we got 3. So we got this as the output. Okay. Okay, so the point was, I wrote if left is not equals to null, then return left. This is a correct thing. But here I failed. See, I wrote or. But if both are not null, then only our root will be the answer, correct? Then only our root will be the answer. I wrote or. So basically right having null, still we are returning the root. Now let's submit and it should work. Yeah, see. So this was the part. If my left plus right both must having values, hence root is the nearest ancestor. Only left node then this, only right node then this. And this was the dry run for the question. Okay, second example. I hope so you understood this. Let's go for the time complexity. It will be, in the worst case, it will be O of n. Okay, because you have to traverse all the node. So O of n in the worst case. And as such, we have no space complexity. So yeah, that's on just plain whatever we have right now. It's on that only. Except this, we are creating a tree node left and right. Nothing else.